Okay. Okay, good evening, everyone. This is Eiman Hassan, presenting from Sudan. Uh, I just I just will introduce myself quickly. I graduated from University of Khartoum, Faculty of Science, Department of Geology, 2004. Then I joined the university as teaching assistant for 2 years. And after that, I joined Schlumberger as geoscientist, software support engineer. After that, I did my master degree in Hertford University, Scotland, UK. Then I came back to Sudan, and now I'm joining a new company called Nubia. I'm working there. So today, I will present for you to which extent GIS can change our perceptions. And this topic is a little bit big, so we will go through specific points on it and overview. So the agenda will be remote sensing and GIS overview. We'll talk about components, usages, and the type of data. Then we will go for preparation of the data for modeling and the applications of GIS, how we can use it, and the softwares are used. I will try to go through the demo quickly as much as we can because we don't have too much time. So this session is designed for fresh graduates. It's a basic, like starting from no one knows anything about GIS. And I hope you all enjoy the sessions. And if you have any questions, I think we can just save the question until the end of the meeting and the sessions. Okay, you hearing me well?
Yeah, well, Eiman, sorry, in display settings, did you share the screen full for the screen?
Sorry?
Can you make your screen full screen instead of seeing the next slide, please, Eiman?
It's a full screen on my.
Do you have two screens in front of you?
So, do you see full screen now?
Display settings. Up. Yeah.
Yes, now.
Is it fine now? Okay.
Yes, fine. Thank you.
So I just turning off the presenter view. It's fine. It's fine. Okay. So we'll start with the remote sensing overview because GIS and remote sensing are complementary. So the remote sensing is the acquisition of information about the object. So if you want to do any GIS processes, we need remote sensing first because it's acquiring the data for us. So remote sensing, it's acquisition of the information without any physical contact. So always it's getting the data without any physical contacts. And the term is applied if acquiring information about the Earth. So usually when we talk about remote sensing, we're doing it for the Earth. Remote sensing is used also in different fields. So it can use in geology, in geography, in meteorology, hydrology, so in military. So there is a lot of department of a lot of segments can use the remote sensing. Remote sensing also is generally refers to the use of satellites. So we're using the satellites to get the data. And it's based on the sensor technologies to detect the objects. And it includes the surface, the atmospheres, and oceans. So all these kind of information, we can get it from the remote sensing. And when we go to GIS, so GIS is a geographic information system. G for geographic, I for information, and S for system. And as we know, so it's starting with inputting data to analyze the data, and then we get the output data. It could be tables, it could be maps, it could be graphs, and it could be reports as well. So the overview also about geographic, there is a different definitions, but it's all in the same meaning. It's a computer-based system for the collections, storage, organization, maintenance, and analysis of special reference data. So we getting the data, we collect the data, store it in our machines, and then we organize it, we analyze it, and then we get the outputs. It depends on what we are doing, what we want to do, or what we want to get. And the data is, it could be any collection data related to the facts. That means there is real facts, real data. And it could be a basic because we're just doing interpretations, modeling from it. Informations, this is what we processed. So we get the data, we do analysis and process it, and then we get informations to answer the questions we have. As we all know, always we say that information, it has to be correct, because if your inputs is wrong or is not real, that means any process, any modeling, any work you do, it will be none of sense. So we know the famous talk like garbage in, garbage out. This is just for you to know that there is another GIS. It's called Geographic Information Science. And this is also underlying about conceptual issues for representing the data. But it's related to science and the theory concepts. And the GI science, or GIS science, is focused on researches in the department, in this department. So it's another kind of GIS. This is about the history of GIS. It starts very early by researchers in universities, 1938, and then John Snow is starting to individually development this methodology of Geographic, 1854, and 1960. Then the development starts to go through the first through operational of GIS in Ottawa. And then it's called Canada Geographic Information System first. After that, it's be the GIS. So if we compare a remote sensing versus GIS, or what the difference, so usually people say remote sensing, we say GIS. So we have to know what the difference between the two terms. So GIS, it's a geographical information system. It's a computer-based, so it's analyzing. We're getting the map, it's tool for the mapping, analyzing and processing the data. Remote sensing, it's for collecting the data regarding the object, phenomena, or the attributes of the object without any physical touch. Remote sensing, it's art of science, making measurements of the Earth. So we measure by maybe airplanes, maybe satellites. So whatever the things we use, it's always regarding collecting the data. Also, a remote sensing, it's relying on the various devices we used. Sometimes satellites, cameras, capturing image. GPS also, it's one of the tools used for the global positioning. So we use some applications of GPS to enter the data out, to bring the data to GIS. So they are completing each other, or they are working in the same goal, or in the same thing. So if we wanted to sum up the overview or to understanding the GIS, so we can just say it's a system designed to capture, store, manipulate, analyze, and manage the spatial or geographic data. We'll go through the meaning of all of these terms, like the spatial data and the geographic data and the difference between them. GIS also is the system that integrates the hardware or software and capturing all the managing, analyzing and displaying the data. And it's a method for, it's a method for visualizing. We can see results using the softwares used for the GIS. Also, it gives us the entities to solve the problem. So if you have an issue, a specific issue you want to know, for example, for example, if you want to compare between area within 5 years, what's happening? Like if you have forest or agricultural area, you want to compare what's happening within 5 years. So you can use the GIS to do this, or to find what the reasons of, for example, getting bad or less forest, what's happening, or like the reason of something. So if you have a problem, you can use the GIS to solve your issue by using the spatial analysis. So in GIS, we have components. So if you want to do a GIS to work with or to use the GIS as a system, of course, the main thing in GIS is the computer facilitated system. So you have to have hardware and software. So this is the main two stuff, but still there is a lot of there is another things we need. We can't work on GIS if you don't have data and we don't have a trained personnel or people to work on these software and hardwares. We need a supporting institutions, researches. We need people to develop the softwares or to develop whatever. If we get a new issues, a new information, so we need a new equation. So we need supporting institutions, and we need a protocol for use the methods. So there has to be specific things you want to do using these methods. For example, for military, you need to have a methods. For geology, you need to have a protocol, specific things, or a specific workflow to work on it. Type. So about components. So this is the details about component. Software and hardware. So I think this is a little bit more details about the components. The hardware, computer associated hardware, GPS, and softwares. It could be number of names like QGIS, ArcGIS, AirDAS, Idrisi. So this is the names of the softwares. We will go through it again. The decisions is based on the institutions. So you need to know what's your entity or your company or your institutions want to do, what their goals, what their problem, and then depends on that you can decide the cost, the number of data, the acquiring data, the training of the people. So it depends on what you require. About the data, it's an important part of GIS. Of course, if you don't have data, you can't process anything, and it's the most expensive component. Hello? So, hello?
Hello,
Yes,
we
ma'am,
can hear you.
Yeah,
We
okay,
can.
fine. So then after we getting the data and starting to build our database, QCing the data, and knowing if the data is applicable to do the work, the GIS work or not, and then we go to the people. The people I think the human resources is very important. So people has to be understanding the GIS. They have to be had experience and they have to be trained well to do the work. And the last one is the policies and institutional frameworks. It's important for functional GIS. So this is just to know the interesting and the protocols of doing the work. So here is the sum up, like a different department or different fields, they can use the GIS. So as you see, the urban planning, for example, education, the real estate, the business, the healthcare. So all this stuff, they can use the GIS in a different ways, with different protocols, with different needs, and with different requirements and data, which is giving us the message that GIS is a very big field, a very big branch of technology, and that it could help in different ways. So the link between all these parties or all these fields is the spatial analysis. So they all depend on the data coming from Earth, and then they start to analyze the data depends on the requirements. So now we can go to the data, the type of data. So firstly, the data, we should have a source of data, and this source could be different categories or different classes, like the coordinates data, longitude, or XY, or locations, buses, or rows. So different way to get the coordinate or the locations of a specific area. The connection information, so I'm talking about geology. So sometimes you have an area and you know geology you don't have information about a specific area, but you know that this area is geologically, it looks like another area, and you have information there. So you can use a connection informations. You can get the same data to start your modeling. Descriptive information, if you don't have if you don't have a data, you can go to the field, making maps, drawing maps, or making analogs. So this is way of descriptive data, or someone can describe something for you if he had information like a knowledge, and then you can use it. A temporal information as well, it's related to the time. If you have different data from different times, you can compare them together using GIS and see the difference. Images, documents, URLs. So this is, all of us are known where we can get this kind of data. So in the data, we have two ways or two terms like semantic and syntax. So usually we use semantics when we have contents, we have the meaning, we know about the data, and we know what is representing in our life or in the reality on the field. But when we talk about syntax, we want to convert it, like we want numbers, we want format, we want to do it like in digital or in something like to be clear or to deal with. So this is give us where we can go for the types. Either it's raster or grid. So this is the main two syntax, or the vectors. We will go through each one to see the difference between the raster or grid. It's the same. So we say raster data, raster file, or grid, or vector. A raster or the grid, it's a uniform pattern, but it's over area be described. So it's giving data by pixels. When we say grid, so that means we have dimensions for each point, and we have value for each point, and to each element value, it's attributed. So we know the value, for example, in each pixel, this is, for example, let's say, a value of any attributes, lengths, elevations, or maybe any other, for example, minerals, specific minerals, or we have either value or code. And for the vector, it's structure points, and it's like a polygons, or it's giving a data without like not like a grid, but a number of vectors could be coming together and giving us like a polygon. So it could be lines, two lines, or at different points we can connect them together or digitize them together to give a polygon. But we are considering it as objects. We can use it for area of interest or for a specific area when we want to calculate, for example, areas, or we can specify a specific area in a field. So usually the vectors is coming either points, line, or polygons, and I think we all know the difference between them, and we will see them later on. So point is give a coordinate x, y, a line is always describe recording coordinates, while polygon is could be something bounded or circled or whatever you can digitize it. A line could be raster or vector, and you see the difference usually between raster and vector. So rasters, it always gives a cell or cellular or a pixel view, and the vector it's just giving a line. So here we can see the difference. If you see, we have a yellow and we have a blue color. So the blue color, we don't have data on those pixels or grids, small grids, cells, and the yellow we have a data. So for example, the first one, row 1 and column 1, this is the data 1, we have a value of 1. But if we go to row 2, column 1, so we don't have data, which is blue. And the other examples is the row 3, column 3, we get data 1. So this is how the raster is being representing in the grid and in the field in the area by pixels or by cells. But the vector, it could be having a starting position x1, y1 and ending position x2, y2. Also, it has attributes like it could be length or width or whatever, any attributes we can apply to vectors, and then it has a direction as well. So if we just want to compare quickly about between the raster and vectors, you will find that file size for the raster is larger and the speed is faster when you copying, processing, and the linking data is easier. You can convert it from format to another format, or to link it with another software. So you can use the raster file in different softwares. But in the vectors, the file size is smaller, speed is lower, and it's a little bit more difficult to use the format of the vectors for all the softwares. So we have a question mark for the accuracy. So it depends on the data you're collecting and the processing you are using and the tools and the efficiency of the softwares of the tools you are using and your experience as well to get which one is more accuracy. So here we see how the spatial data present in GIS. As we say, the vectors, it could be point, lines, or polygons area in this on the picture on the left. So the polygons are just segments or segmented by lines. So could be the polygons, points if you have a specific points, and lines like on a street or whatever in the grid. So each pixel, it has to be defined as For example, water or grass or forest or urban or whatever, it depends on what are you working on. But each cell with a specific dimension, it has to be defined with attributes or with a value. So the spatial data here, we have two different terms, spatial or geospatial data, and we have geographic or geoinformation data. So the geospatial data is usually coming and connected to a known place on the earth, where it always has a phenomena in a specific location. So you get a phenomena for this. And it could be displayed or it could be defined by coordinate system, latitude, longitude, or coordinate system, or postal code, or electrical area. So you have something to define the place, where is it, or the location of this data. But the geographic informations or geoinformation data, it is specific type of informations. So it's coming from the interpretations of the spatial data. So we are using the spatial data to get the geographic informations or the geo informations. So there is two important components for the geospatial or geographic data. We need a position and we need attributes. So we have to know where the data is and what the data is regarding to, so the attributes of this data. The geographical position is specified in the location. As we know, it could be used by the coordinate system. And attributes, it's referred to different properties. As I mentioned before, it could be water, it could be forest, it could be kind of minerals, it could be whatever. So it depends on the field you are working on. And the GIS softwares usually using the data management system to handle these attributes and to display it in the after processing. So GIS also, it's giving us the link between the geographic data and the spatial data, because we are linking the positions with the attributes, and then we get starting the analyzing the data. So we get back to the source of the data. So GIS can handle the data from different sources. As you see in the screen, for example, from the maps, from the digital data, from the aerial photographs, from the GPS devices, surveying, imagery, scanners, drones. For all these tools could be sources for the GIS. So one of them is the Earth observation data. This is commonly gathering the information about the planet, and the data coming from the satellites, from remote sensing. All this we call it, we use it as observations data. And data collected from GPS, برضو imported, so the data collected by GPS also imported to the GIS system, because GPS is giving us locations or positions at the end. So we need the positions and we need the attributes for the GIS. So if someone doesn't know, GPS is one of the global navigation satellite system. And there is another tools for this for the global navigation system, and examples GLONASS and Galileo in different countries. So here we're talking about the existing digital data. So if we have data already there, already in raster files or in digital files, we can use it directly to GIS or to the softwares. We can just convert it from software to another softwares. if we have digital maps, data sets, also we can use it. So the data model we're talking about, so we have two kind of data models, either raster data model and a vector data model. And this is the only two options used by GIS. And we said the vectors is close. So the vectors is close to the traditional mapping. That means it represents as point, lines, areas, features. So it looks like the maps, but the positions at the end is the same. So we are positioning them with the coordinate pairs, and we import it into the softwares out of the GIS. A raster data model divides the geographical space. Either we have a regular grid or square cells like pixels. So each one or each number representing specific attributes, as I showed in the picture before. Examples of raster data may be stored electronic imaging or picture taken as aerial photograph or satellite image. So most of the GIS, they're using the satellite image for doing the processing and the analyzing of the data from the satellite image. So this is a common and very clear demonstrations picture using a real world in the bottom. So you see the area with water, with some agricultures, and then we see the vectors. So when we say the vectors, it's near to the reality. So you can draw it. So the water the blue is in the lake, and where you get a little agriculture is marsh, and then we have island somewhere, and we have an urban, so that some areas. So we have like 4 codes when we do a raster model. So the cells will be either yellow for marsh, or either blue for lake, or green, or pinkish. So this is how we convert the real world to vector models and then to raster models, with giving attributes and value for each cell. So a question is always raised: how does a GIS answer spatial questions? So the GIS always giving the data from the physical world to display it in layers. So we can get input and edit the data inside GIS using the spatial and attributes data. And we can display the data on the screen, or printing a map, or analyzing the maps. So the analyzing, it's for decision making for the entities to decide either they work on this area or no, they want to solve an issue or no, to drill in somewhere or no. So they need to decide on a specific manner. So they need to analyze and get the data. And also we're creating the models and asking if this model is correct, what will happen, and if it's not correct. So in this point, we're going to the risk, and we're going to the probabilities, and we're going to uncertainties. So it's give another track of work, depends on the protocols we used. So if we go to the tools of GIS, so the first tools used for GIS is started at universities as small researching tools in Harvard, Yale, and Clark universities. And there is a lot of tools like Idrisi, AutoCAD, AirDAS, ArcGIS. So there is QGIS, a lot of them. So people are using it. It depends on the entities, what they want, and what their budget, and what the capabilities and the number of people they have and the experience. So it depends on that. Entities are.
I need your consent on a few items to continue.
Okay. So we now coming to our questions on the title of our presentations. To which extent GIS can change our perceptions? So if we see now, it's clear to us. So we need data input and pre-processing. We make transformations of the spatial data, either it's maps or image or points. We need to store this data and retrieve it. Like we want to import it in GIS softwares, in computers, and then we need to process it and do it, and then we can get it back. We need to manipulate our data and analyze, making modeling, simulations, estimations. Either we are working on mining or healthing or environments, and we need to report and display all the information. So this is like what we have all in GIS, what we are doing in GIS. So to which extent GIS can change our perceptions, we need to answer the questions. Where are particular features found? That means what we are looking for. What geographic patterns exist? So the attributes we want, and where we have change occurred over specified time periods. If we are comparing different times, different features or patterns change through times. Where do certain conditions apply? Where we can find different conditions, and if we have it, where to do apply it. And what will be the implications if an organization takes a certain actions? So we're going here to the decision making. So this is the questions we need to answer by GIS, or we need to answer by us when we are working on GIS. So to answer the questions, we will go through quick comparisons between stuff, because so I will compare between GIS, analogs or the digital and the analogs quickly. As you see here, the real world is drawing a map, and then in the digital we have numbers and pixels, and so we can compare numbers, we can compare and get a quick answer or a specific answer. This is a comparison applied between tradition maps and geographic. So showing in the maps, the data collection, it could be the maps, collections from the photos, surveys, and in GIS, collections from the same aerial and photos and surveys. Processing is the same. Plus, in GIS, we are using circular processes. So what we mean by circular process, that means when we generate map, we can enter the results we get in another process to generate another map. So this is called a circular process. We can't do this in the map or in the analogs. So in the map production, we have final step except for reproductions, and so that this is what I mean. Like we can't use the map to generate another map, but in GIS we're using the same map to generate or to produce another results. Here it's a comparison for the input subsystem functions between a map and GIS, or analog and digitals. In the maps, we have point, lines, areas, and we have the same in GIS, but in the sources, it could be a difference. So in the sources in GIS, we have digital lines, digital elevation models, digital ortho quads, so we can get data source from different or from digital, but in the analogs, we can't get it. It's all from statistics or visual descriptions from field of surveying or remote sensing. Another comparison between retrieval subsystem functions. So in the maps, we have point lines, areas, drawing in the papers and symbols. But in the GIS, we are using the computers, and you can apply more. You can produce more fancy maps and more accurate stuff by computer. Retrieval is simply a matter of map reading. I know it's not easy to read the map if someone doing it, but it's very easy and efficient if it's used by computer, so everyone can read it and can get to the legend and the symbols and understand what's on the map. So this is also about analysis. So in the map, if we want to analyze a map, we require rulers, plane meters, compasses, and other tools. In GIS, we're just using the power of computer, so we have all this measurable stuff and measuring and comparing the descriptions. We have it in calculators and in the softwares, inside the softwares. So you just click on anything and you get it. Restricted in the map, it's restricted to the data as they are aggregated and represented on the paper map, but in GIS, you can access the new data and allow aggregations and reclassifications for further analysis. So, still the answer of the question to which extent GIS can change our perceptions, the answer will be so this is in the power of GIS, and this is the power of us, the people are using the GIS. So the interaction between database and the maps, along with ability to create graphs, table, and reports, and this is the outputs we get from the GIS. So I think we have some times to do demos and see the questions. Before that, I just want to show you a generic workflow. So as we say, usually first we are collecting the data, and after we collecting our data, then we are using remote sensing for collecting the data, and then we do the field integrations. After that, we start to create our plans for the data collection. If we have a digital data, another data, and if we need to scan some photos or some documents or some information from other sources, if we need to digitize areas, making area of interest, also doing the area photography, map production, area estimation. So this is a GIS work, and then we get the results, and then we apply, we're taking the results for our application for decisions making to what we want to do. Thank you for your attending the sessions. Before starting the demo, let me see if there is any comments or questions. Hello, any questions? Any comments?
No question, but thank you for the lecture, and we are looking forward to attend more lectures with you. Thank you.
Thank you. Okay, then let's go for a few minutes of demo. So I just wanna, so there is a lot of softwares, we can go through all of them. So I just wanna show you the important things we need to do for and the GIS. So is to download the maps to use it in GIS. So this is could be done from different websites. Let me change the sharing. Okay, so you are seeing now my Google window, yeah? So, so those are, I have like 3 websites. You can download picture of them. So this is called Earth Data. I can send the links for you if you want to download. So you get started and find your data. And this is a little bit older. This is another one. It's called Earth Data USGS. Earth Explorer, so you can also download your data from here. So I will work on this one. It's the last or the best one of them. So this is called USGS Glovis. So you need to log in. So I'm logging in already by my name, but you need to do an account and then to log in and download the data. So if you see here, there is a different data sets. So this is the satellites types. And you select whatever you want, depends on the bands and the levels and the time of satellites. There is a different way of doing this. So let's assume we are using Landsat 8. You just need to put it on. You need a good internet connection, so I'm sorry if it's a little bit slow. So wherever you're moving by your mouse, are you seeing my screen well?
Yes, we
Can
can.
you just write it down? Yeah. Okay. Okay. So when you move with your mouse, you are seeing here the latitude and the longitude. The location is changing. So this is showing the home, the default locations. It's turning you to US, I think. Here the option to select where you want or what the location you need. You have options to send it by, for example, to search by latitude and longitude if you have the coordinate system, and you just write it down and jump to any locations, or otherwise you use a sense ID or pass or row. So you know the word is divided to passes. Each pass has, I think, 119 rows. So you just know the area where you want to capture an image and download it. You enter your pass and your row. And if you just want to download any area without having any longitude, you know the place. For example, we are in Sudan. Let's say here where we are here somewhere, and then wherever you click, it's bounded the image for you. So you see here, it's a little bit So this is around south of Khartoum, Sudan. You see, this is the River Nile, the White Nile, and this is the Blue Nile. So if you want to download the pictures, it's just very easily. There is an option here for download, and then you are using the format you want to download. There is different format and even different kind of image. So it could be natural color image, it could be thermal image, it could be quality image. So there is different kind of different type of images, and whatever. For example, we downloaded for level 1 data products TIFF, and you just click on download, and then you select the path you want to download on it on your PC or on your laptop, and then you can use it in any other softwares. You go to the softwares and then you import your data and then start all the processing. In each softwares, there is different softwares. In each software, there is a different models, a different workflows you can use. Depends on your requirements. So this is just a quick informations about this, and I can send you the link, and then you can try this yourself. I just wanna say at the end. So the output of all the GIS, it maps, tables, and reports. You can make graphs, you can make reports from it. And this is what I have for today. Thank you very much, and let me know. I will check the comments if there is any questions. Thank you very much. So we have, I think, 3 to 5 minutes if you have anything. Thank you. Okay, someone asking for sharing the presentation. I will pass it to PetroNile Academy, and then they can see what they can do. Thank you for all the people saying thank you for me. Thank you for your attending and your time. I hope this is joyful and informative for you. And I'm so happy to be one of participants on this and these sessions for PetroNile Academy and EEG. Thank you very much.